Okay, so in this video, I am going to show you how to conduct an independent samples t-test using Stata. And so to start off, you'll see that I already have Stata open. I've already got some data loaded into Stata. And then, I've got my list of variables over here that I can, scroll through. And then down here is some information about, each variable that I might select, and then the data set overall. And so this data set, just as background, comes from the New Jersey Department of Education. It contains every public school in the state in the 2018-19 school year. And so for an independent samples t-test, so this is when you're looking at, you want to compare two different groups, non-overlapping groups. So that means you want to compare, say, the achievement of two subgroups of students, or you want to compare the student achievement, in two different states or something like that. So you've got two mutually exclusive or non-overlapping groups, and you want to compare some sort of an outcome or characteristic or variable between them. So that would be an independent samples t-test. So you're comparing groups. Let's say that we want to compare high and low poverty schools, and let's say that we want to compare, what we're interested in is whether high and low poverty schools have different rates of SAT participation. So one thing we might notice after going through the data, which I've already done this ahead of time, is that we don't actually have a variable that indicates whether a school is high poverty or not. The data set does give us this variable. It says economically disadvantaged students. But that's a continuous variable. It doesn't say this school is high poverty, this school is low poverty. So what we could do is we could use this and we could turn this into a categorical variable. And so let's say that we want to see how we should break this up. One thing we could do is make a histogram of this particular variable and kind of eyeball it and see where there are maybe some natural groupings. And so it could be maybe we say break this into thirds or something like that. What I'll do here is, let's just say that if a school has 30% or fewer of its students are identified as economically disadvantaged, we'll call that an affluent school. If a school has 70% or more of its students who are economically disadvantaged, then we'll call that a high poverty school. And so what we need to do is we need to create a variable that codes this. So we'll just, we're going to create a variable, and we're going to call this variable high poverty school. And we want that to be a 1 if this if the percentage of economically disadvantaged students is greater than 70. So that's going to create a new variable for us. It's going to have a value of 1 if that school has more than 70% of its students identified as economically disadvantaged. Now we want to use this in a comparison, so we also need to flag the schools that are low poverty or more affluent. So the easiest way to do that is just to code this as a 0. And if the number of economically disadvantaged students is less than, we said 30. And because we've already created this variable called high poverty, we want to just use this replace command. So what this will do is, for this variable high poverty, it'll go through the data in each school that has fewer than 30% economically disadvantaged students. It will give this high poverty variable a value of 0. And if we wanted to check and make sure that it did what it's supposed to do, so we can say make a histogram of this percentage economically disadvantaged if high poverty equals 1. So we'll see it starts over here just above 70, which is exactly what we told Stata to do. And we could do the same thing for 0. So this would be our low poverty or more affluent schools. And we'll see that it maxes out at just under 30. So what this means is that when we made this variable called high poverty to separate our more affluent schools in one group from from the more economically disadvantaged or more economically challenged schools or high poverty schools, whatever you might want to call them, as the second group. So we've got two groups here. And one thing to keep in mind when you're doing a t-test is you can only compare two groups. And so if you're thinking, well, what about all those other schools in the middle? And so what we're doing here is we're actually leaving them out. So any school of, we might say like a mid-poverty school that has between 30 and 70% of its students identified as economically disadvantaged, those schools are not going to be included in this analysis. And whether or not that is a good thing or a wise thing all depends on your research question. So that's just something to keep in mind. So now we've got our data set up by creating this categorical variable, or this binary variable. Binary variable is a categorical variable with two values. We can use this now to do an independent samples t-test. So let's say we want to look at, again, it's SAT participation, and we want to see if the percentage of students who take the PSAT in high poverty schools is different than the percentage of students who take the PSAT in low poverty or more affluent schools. So let's say that's our research question. Then to answer that, we use the t-test command. And so we just say t-test, and then we use, let's see, SAT participation. So this is sort of our outcome variable. If we're thinking of it that way, this would be like our dependent variable. And so we'll use the by option for high poverty. So this is our grouping variable. So this is, and again, we can only have two groups. So we've got this variable high poverty that contains, it's two categories. So again, this distinguishes our low poverty schools or more affluent schools from our high poverty schools. And so down here in this table, we'll see some descriptive statistics across the first two rows. And so group 0, so these are the low poverty schools. So there were 214 schools identified as low poverty. The average SAT participation across those schools is 77%. And so this is going to be of graduating seniors or juniors. That's who's used to get this percentage. The standard error of this percentage is 0.81. Then we've got information on the standard deviation, and then the confidence interval for this mean of 77% SAT participation in low poverty schools. Then this group number 1, so this is our high poverty schools, which we defined up here. So greater than 70% students are identified as economically disadvantaged. There are 58 of those schools in our data. The average SAT participation is 85% actually. The standard error of that is 2.89, 2.9 will round. Then there's the standard deviation, and then the confidence interval for this mean. So down here, when we look at the row that says combined, so this lists the total number of observations that are used for this analysis, so 214 plus 58, 272. Then this gets us the, so this is the overall mean. And then what we're seeing here is the standard error of the combined overall mean, standard deviation, confidence interval of the overall mean. But then down here, what we'll see is for the difference. So this is the difference between these two values here. So the low poverty schools minus the mean for the low poverty schools minus the mean for the high poverty schools. So it's a difference of 7.85 plus %. The standard error of this mean difference is 2.17. And then there's the confidence interval, which ranges from -12 and change to -3.6. And so what you might notice is this confidence interval does not contain 0, so this is going to be statistically significant. But to be a little bit more precise about that, we can come down here to this these two rows kind of right here in the middle. So what this tells us is for the null hypothesis that there is there's no difference in means between these two groups. And so in this case, to restate that using the variables that we're using is that the percentage of students who take the SAT in high poverty schools is the same as the percentage of students who take the SAT in low poverty schools. What this tells us is that this gives us the p-value for that null hypothesis. And because the p-value is less than 0.05, we can reject that null hypothesis and conclude that there is a meaningful difference in SAT participation between high and low poverty schools. And as we can see, something to keep in mind is that in this case, maybe you're sort of a priori, this might be a little bit different than what you may have thought. So what this means is that high poverty schools actually have a higher percentage of SAT participation than low poverty schools, and that difference is statistically significant. So that's how we can use an independent samples t-test.